Hello all, welcome back. Now we'll be discussing about the hypothesis testing in detail. We make a decision about population or population parameters based on sample statistic or samples. Whenever we make a decision about the population or population parameter, we make an assumption about the population parameter, and this assumption is known as the statistical hypothesis. In other words, we can say, like, we make a claim about the population parameters, and more precisely we define hypothesis as a quantitative statement about the population. Suppose we make an statement that the average weight of the student in Chosun University is 65, and here is the uh, claim or assumption. And once we make claim or statement, then we have to check the validity, and in order to check the validity we will go through the hypothesis test. And there are basically four steps for the hypothesis testing. And first we have to state the hypothesis, then we set the criteria for the decision, and in the third step we compute the test statistic, and finally we make a decision. And to begin, we identify the hypothesis or claim that we feel it should be tested. And basically there are two mutually exclusive hypotheses. One is the null hypothesis and another one is the alternative. The null hypothesis is stated as null is a statement about the parameter, such as the population mean, that is assumed to be true, or it's a claim or a statement about the population parameter that is assumed to be true until it's declared to be false. And we test null hypothesis for the possible rejection under the assumption that is initially true. And another hypothesis is an alternative hypothesis, and it is written as H subscript 1, and it can be also written as H subscript A. And it is a hypothesis which is complementary to the null hypothesis, or it is a statement that directly contradicts a null hypothesis by stating that the actual value of population parameter is less than, greater than, or not equal to the value that is stated in the null hypothesis. Okay, let's see an example. Suppose a manufacturer of cold drinks that claims that on average 500 milliliter of beverage is filled in each bottle, and here the manufacturer claims that the bottle is filled with 500 ml of beverage, and it is a claim about the parameter, and here parameter is the average beverage that is filled in the bottle. And here our null hypothesis is an average. In an average, each bottle contains 500 ml of the cold drinks, that is H naught is equal to, here mean is equal to 500 ml. And we have made an assumption about the population parameter, and we move on assuming it's true. And next is we make an alternative hypothesis, which is H1 here, and H1 is that mu is not equal to 500 ml, that is the bottle doesn't contain 500 ml of beverage or cold drink. And we call this two-tailed test when the alternative hypothesis consists of not equal to symbol. Here when it consists of not equal to symbol, then it will be two-tailed test. And or there may be another scenario where the bottle contains in average less than 500 milliliter of the beverage and it is one tail test. Similarly, the bottle contains another hypothesis where the bottle contains more than 500 ml of the beverage, and here we can see when this alternative hypothesis uh, has a not equal to sign, then it is two tail test, and when it has less than or greater than sign, then it will be the one tail test. And for this two-tailed for this alternative hypothesis, we call one-tailed test, and the hypothesis test with the average or less than 500 ml is the left-sided tail, left tail test, and hypothesis with the greater than symbol will be the right tail test. Once we set the hypothesis, we state the level of significance for a test. Well, while we take the decision, the possible outcome can be we may reject the null hypothesis or we retain the null hypothesis. The success of test is determined by the rejection of the null hypothesis. That means our attempt is to reject the null hypothesis. So if we reject the null hypothesis, we will also accept the alternative hypothesis, and if we accept the null hypothesis, then we will be rejecting the alternative hypothesis. Now question arises, when should we reject or accept the null hypothesis, or how to set the criteria for the rejection or acceptance of the null hypothesis. And let us see a simple example of non-statistic example, like for students who attempts an exam, the full marks is set to 100 and 40 as a pass mark, and here we can say that 40 is the level. If he scores greater than or equal to 40, then he passes, otherwise he will fail. So we can say that 40 as the level, and analogous to exam score, we can apply, like we can we can set the level of for the rejection or acceptance for the null hypothesis, and it is known as a significance level or alpha level. It is denoted by alpha. In hypothesis testing, this level of significance gives us the probability of error in rejecting or accepting the null hypothesis, and it's denoted by alpha. As we can say that it is the level of we can also say it as the level of rejecting the true null hypothesis, and in general it is set as a 5%, 1%, or 0.1% of level of significance. And this means that this 5% 5% of level of significance means that there is the 5% probability or chance of making the wrong decision. That means out of 100 decision, we have chance of making 5 wrong decisions, or we like while we accepting the null hypothesis, we have 5% chance of accepting the wrong hypothesis, or while we reject the null hypothesis, then there is a 5% chance of rejecting the 5% chance of rejecting the true null hypothesis. That means, like, out of 100 decisions, suppose if we are making 100 decisions, we may have chance of making 5 wrong decisions. Once we set the level of significance, then we have to decide which type of test will be applied, and you can apply two-tail test or one-tail test as described before. When alternative hypothesis consists of not equal to sign, then we apply two-tail test, and when alternative hypothesis consists less than or greater than sign, we will apply the one-tail test. And here we apply two-tailed or one-tailed test on the basis of on the standard normal distribution curve, and we apply one or two-tailed test. And let us see for the two-tailed test. Here we set the alpha level is equal to 0.005, like this is our standard normal curve. We take the decision on the basis of this curve, and here is the standard normal curve, and the area under curve is 1, and it is symmetric about the mean. And we can say this means 0.5 on the left side and 0.5 on the right side, and we can see both tail on the left side and the right side. And as we have two tail test, we divide this alpha in half so that an equal proportion of area is placed under the placed in the upper and the lower tail. That is, the alpha value will be divided by 2 on the left tail, and alpha divided by 2 on the right tail. So the alpha level will be 0.05 here, and it's 0.025 on the left side and 0.025 on the right, and remaining 0.475 on the left and 0.475% area on the right will remain around the mean, like around this mean. This is the 0.475 area on the left and 0.475 area on the right of the mean. And in aggregated, like in total, it will be 0.95 area. It will remain around the mean. So the area covered by alpha by 2 on both sides is called the rejection region. While performing the test, if the value of test statistic fall within the region, like this region of rejection, then we will reject the null hypothesis. And when the result of the test statistics fall within the region of acceptance, like within this region around mean, and we will accept the null hypothesis. And a critical value is the cutoff value that defines the boundaries beyond which less than 5% of sample means can be obtained if the null hypothesis is true. And here the sample means obtained beyond the critical value will be a result in the decision to reject the null hypothesis. We can estimate the value of this area from the standard normal table from mu to critical value, and here we can see the point is mu plus 1.96 sigma. It is like from mean plus 1.96 standard deviation to mean minus 1.96 standard deviation. It is for two-tailed, and we have taken the alpha by alpha divided by 2 because both sides will contain the rejection region, and in acceptance region we will accept the null hypothesis, and in rejection region we will reject the null hypothesis. And it's for 5% level of significance. We can make it for 1% as well as other. We can see like this table here gives the critical values for the 1 and 2 tail test at 0.05, 0.01 and 0.001 level of significance. This is the table we can see, and on the basis of this we will take the decision. And let's see for one tail test, one for left tailed and next for the right tailed. Both are symmetric about mean, and when alternative hypothesis contains greater than sign, then we will apply the right tail test, and the rejection region will lie on the right side, and if we set alpha equal to 0.05, then the recession region will have the 0.05 area, and the remaining area or the remaining region will have 0.095, and the critical point here is 1.645 of sigma. It is plus 1 point, we can see here, like this is the 1.645 of the sigma. And for left tilt, the alpha will be like when the alpha is 0.05, and the recession region will lie on the left side, and if we set alpha is equal to 0.05, then the recession region will have 0.05 area, and the remaining region will have the 0.95, which is the acceptance region, and the critical point will be here minus 1.645 of sigma at this point. Now the next step is to calculate the test statistics. We can take various tests like z-test to t-test or chi-square test, and z-test is applied when the sample size is greater than or equal to 30 and the standard deviation population is none, and it follows the standard normal distribution, and we estimate the z value using this formula, like this z score is given by this x bar, this is the sample mean minus population mean divided by the standard deviation of the sample, and this standard deviation of sample is estimated on the basis of population standard deviation, and it is estimated as population standard deviation divided by the root n. This n is sample size, and when the sample size is less than 30 and the standard deviation of population is not known, in this case we use t-test. Here the t-score is obtained as this x bar minus mu. X bar is nothing but the sample mean minus population mean divided by the standard deviation of sample. And now in step 4 we will take the decision. Here the decision will be, we will either retain or reject the null hypothesis, and we make the decision on the basis of calculated test statistic value and the level of significance we set. Like we have the z value as a test score, and we have a tabulated value of z as the alpha level of significance, and if the calculated z or the obtained z is greater than the tabulated z, then we reject the null hypothesis, which means there is a significance difference between the sample statistics and the parameter. Here while taking the decision, we have taken the modulus, and it is taken because this z is symmetric about the mean, and it may have positive as well as the negative value. So if we calculate less than the tabulated z, we will accept the null hypothesis, which means there is no significance difference between the sample statistic and the population parameter. And if the calculated z is greater than the tabulated z, then we will reject the hypothesis, which means there is a significant difference between the sample statistic and the population parameter. We can also take the decision on the basis of p-value. This p-value is nothing but the probability of obtaining a sample statistic as different or more different from the parameter specified in the null hypothesis, given that the null hypothesis is true. And when the p-value is small or close to 0, then there is a little evidence that data come from the distribution given in the null hypothesis. And when the p-value is not small, then there is the evidence that the data do come from distribution given by the H0 or the null hypothesis. In other words, a larger P indicates that a little or no evidence against the H0 or null hypothesis. And in step 2, we stated the criterion or the probability of obtaining a sample mean, at which point we will decide to reject the value stated in the null hypothesis, and it is typically set as the 5% or 1% in the behavioral research. And to make the decision, we compare p-value to the criterion set in the step 2. Basically, we get this p-value from the standard table, like from z value we can get the corresponding p-value of the z value. So once we estimate the z score, then we can get this p-value or the probability value. And when p-value is less than 5%, that is p less than 0.05, we reject the null hypothesis and we refer to p less than 0.5 as a criterion for deciding or to deciding to reject the null hypothesis. Also note that when p is equal to 0.05, the decision is also to reject the null hypothesis, and when p value is greater than 5%, then we will retain the null hypothesis. The decision to reject or retain the null hypothesis is called the significance. And when p value is less than 0.05, we reach the significance. The decision is to reject the null hypothesis. And when the p value is greater than 0.05, we fail to reach the significance, and the decision is to retain the null hypothesis. In step 4, we decide whether to retain or reject the null hypothesis. As we are observing the sample, not an entire population, it is possible that conclusion may be wrong, or we may have some error in the decision. And there are 4 decision alternatives. The decision is to retain the null hypothesis could be correct, or the decision to retain the null hypothesis could be incorrect. And while we reject the null hypothesis, the decision to reject the null hypothesis could be correct, or the decision to reject the null hypothesis could be incorrect. As mentioned before, when we decide to reject the null hypothesis, we can be correct or incorrect. And the incorrect decision is to reject the true null hypothesis, and we call this decision as an example of the type 1 error. And with each test we make, there is always some probability that our decision is of the type 1 error, as we have mentioned before. That's why we set the level of significance, and it is defined by alpha. Like when we set alpha is equal to 5%, and there is always chance that we are going to take the in our decision there is 5% chance of the type 1 error. And here a researcher who makes this error decides to reject the previous notion of the truth that are in fact true. Like it is defined, suppose if the claim of the hypothesis, null hypothesis, is true, but the researcher is rejecting that truth. And another one is the type 2. Like here, when we decide to retain the null hypothesis, we can be correct or incorrect. The correct decision is to retain the true null hypothesis. The decision is called the null result or null finding, and the incorrect decision is to retain the false null hypothesis. And this decision is an example of the type 2 error, or we call this as the beta error. And with this test we make that there is always some probability that the decision could be type 2 error, and it is defined by this beta. Now let's go for an example. That the Templer and Tempio in 2002 reported that the population mean score on the quantitative portion of the GRE, the Graduate Record Examination, general test for the students taking the exam between 1994 and 1997 was 558 plus minus 139 means the average score was 558 with the standard deviation of 139. And suppose we select a sample of 100 participants, that is n is equal to 100, and we record the sample mean to be 585. Then compute one independent sample z-test for whether or not we will retain the null hypothesis, that is population mean is equal to 558 at the 0.05 level of significance, that is alpha is equal to 0.05. Here what we are given is like we have got the population mean and its standard deviation, that is 558 and 139, and the number of participants, the number of samples of sample is 100, and the sample mean is 585. M is equal to 585. Now we have to test whether the null hypothesis is correct or not. Like first what we have to do is we will state the hypothesis, and here the population mean is 558, and we are testing whether the null hypothesis is equal to or not equal to correct. So here the null hypothesis S naught is M is equal to 558, that is mean test score are equal to 558 in the population, and our alternative hypothesis is this is not correct, or M is not equal to, the mean is not equal to 558. That means the mean test score are not equal to 558 in the population. And then next we set the criteria, and here we set the level of significance to 0.05, which means there the alpha level is equal to 0.05. and now we will locate the z scores in the standard distribution, in the standard normal distribution, that are cutoffs or critical values. And for sample mean values is less than 5% probability of occurrence if the value stated in the null hypothesis 558 is equal to true. And in non-directional two-tailed test, we divide the alpha value in half, so that the equal proportion of area is placed on the upper and lower tail that we had already discussed. Like we split the alpha in half, then the alpha value will be 0.025 in the left tail and the 0.025 in the right tail, and this is the alpha level of significance and its z corresponding critical values. And we can see the rejection region and the acceptance region and its critical values for the non-directional two-tailed test when we set the alpha is equal to 0.05, as we discussed in our previous slides. And step 3 is to compute the test statistic. In this step, we will compute the test statistic to determine whether the sample mean we selected is beyond or within the critical values we stated in the step 2, and that the test statistic for one independent sample z statistic is called the z statistic. As we have discussed before, there are various types of test statistic that we can use, basically on the basis of the number of samples and the standard deviation of the population is given or not. And the z statistics is an inferential statistic. It is used to determine the number of standard deviation in standard normal distribution that a sample mean deviates from the population mean stated in the null hypothesis. Here for z statistic, we have got the z obtained is estimated using the difference between the sample mean and the population mean divided by the standard deviation of the population, and we estimate the standard deviation of population by dividing the population mean by root of n. Here n is the sample size, and in our case, our first we estimate this standard deviation of the sample, and here we have got the standard deviation of population to be 139, and we have the sample size of 100, and we get the standard deviation of this some sample to be 13.9, and then we obtain the z value, which is just once we plug these values, like here the population mean is 585 and the sample mean is 558, and we plug these values here and we get the z obtained to be 1.94, and the obtained value is the value of test statistic, and this value is compared to the critical values of the hypothesis test to make a decision. And when the obtained value exceeds the critical value, we decide to reject the null hypothesis, otherwise we will retain the null hypothesis. And here is we make a decision, and we compare the obtained value to the critical values, and we reject if the null hypothesis we reject the null hypothesis if the obtained value exceeds the critical value. And here like if we compare this with the figure, then the z obtained is 1.94, which is less than the critical value, and that's why it does not fall in the rejection region, so we will retain the null hypothesis. As we can see, the critical value for two-tailed non-directional test is 1.96, and our obtained z value or z score is 1.94, which is less than the critical value, so we retain the null hypothesis. Now we can make the decision on the basis of p-value as well. So the probability of obtaining that z obtained is stated by the p-value, and we can locate the p-value or the probability of obtaining z statistics using a unit normal table. Here this is the unit normal table, and here is the z value, and this is the corresponding p-value, and we can see here that here in our case that when we refer to this table, we get the value to be 0.0262, and as we are using the two-tailed test, here what we have to do is we multiply the value in the given column times number of tails in the alpha, and we have got two-tailed test, and we multiply this 0.0262 by 2, that is we get 0.0524, and here is our table. And here what we found is that if the null hypothesis were true, the p would be 0.054, that we could have selected the sample mean from this population, and this criteria we set in the step 2 was probability that must be less than that we obtain less than 5% that we obtain a sample mean if the null hypothesis were true, and we see here p is greater than 5% or 0.05, we decide to retain the null hypothesis, and that's why we conclude that the mean score of the GRE test in this population is 558, which is the value stated in the null hypothesis. One thing to be noted here is while taking the p-value of the z score, we, as I mentioned in the previous slide here, like while we take the decision, we can take the modulus of the z obtained or z calculated and compare with the level of alpha significance. It is only when we take decision on the basis of z score, but when we take the decision on the basis of p-value, then what we do here is we keep the z-score or the sign of the z-score as it is. As we can see here, we can get the z value from negative 3.3 3.4 to positive 3.4, and we can see like this negative 3, this negative z value, it indicates the z value for the left tail, and the positive value, it indicates for the right tail. And while we take the probabilities, like we can see here, the probabilities given in the table represent the area of the left z-score and the area of the z-score, is taken as a 1 minus area of the left score. So while we estimate the while we take the p-value, what we do is we once we take this, then we subtract this area of the left z-score by 1, so that will give us the accurate z value, p-value for our corresponding z-score. And we can see here, like we have found the p-value to be 0.0524, and that could have like that could have selected the sample mean for the population. This was the probability that we could have selected this sample mean for this population. And as we set the criteria in step 2, it was the probability that must be less than 5% that we obtain the sample mean if the null hypothesis were true. And we can see here this p-value is greater than 5%, and we decide to retain the null hypothesis. That's why we conclude that the mean score of the GRE general test in this population is 558, which is the value that is stated in the null hypothesis. So it's all about our test, hypothesis test, and we can use use same steps for the t-test as well, and only the difference is that number of sample size and the test steps that we like, the test statistic procedure. Like the only the difference is the test statistic calculation step, and it is determined mainly by the sample size and the availability of the standard deviation of the populations. So in our next class, we'll be discussing about the more inferential statistics that is used for the predictive and the diagnostic analytics, and additionally we will be also discussing about the prescriptive analytics as well.